Okay, so I can see two areas here. I'm going to consider the first area, the area trapped between the function and its inverse, is really got a line of y equals x through the middle. So I'm going to consider this first area as being the integral from 0 to 1/2 of x being the top curve minus 2x squared being the bottom curve dx, and then double it to get the full area trapped. So we've got two lots of x squared on 2 minus 2x cubed on 3 from 0 to 1/2. So it's going to be 2 times 1/2 times 1/2 squared minus 2/3 times 1/2 cubed minus nothing plus nothing, which is two lots of 1/8 minus, so I've got 2/3 times 1/8, which is 1/8 minus 1/12. We'll get that, yep, 1/12, which is going to be two lots of, if that's going to be on 24, we're going to have 3, so 3 minus 2, which is going to be two lots of 1/24, which is 1/12. So the first area, this area is going to equal 1/12. The second area, this red area, is going to be the integral from 1/2 to 1. The top curve is going to be 2x squared, and the bottom is going to be 1 on root 2, x to the 1/2 dx. And that's going to equal 2/3 x cubed minus 1 on root 2, x to the 3 on 2, on 3 with the 2 on the top, from 1/2 to 1. So when I place my 1 in, I'm going to have 2/3 minus 1 on root 2 times 2/3, then minus 2/3 times 1/2 cubed, then plus 1 on root 2, 2/3, 1/2 to 3 on 2. And that's going to equal 2/3 minus 2 on 2 root 3 root 2, then I'm going to multiply that by root 2 on root 2 to rationalise the denominator, minus 2/3 times 1/8 plus 1 on root 2, 2 on 3, 1 on 2 root 2. It's going to be 2/3 minus root 2 on 3, because the 2 will cancel with the root 2 times the root 2, minus 1 on 12, plus the 2 cancels with the 2, that's going to be 1 on 6. So all up, I've got my 1 on 12 that I had over on the first area, plus 2/3, minus root 2 on 3, minus 1/12 plus 1/6. The 1 on 12ths will cancel to leave me with 2/3 plus 1/6 minus 2 root 2 on 3, which equals all on 6, 4 plus 1 minus root 2 on 3. So 5/6 minus root 2 on 3, or 5 minus 2 root 2 all on 3 square units.